Everybody, I'm Donna Spiegelman. I'm Susan Dwight Bliss Professor of Biostatistics here at the Yale School of Public Health and the Director of our Center for Methods and Implementation and Prevention Science, which is very pleased to be co-sponsoring this talk along with CIRA, the Center for Interdisciplinary Research on AIDS at Yale University, and the HIV Implementation Science Coordination Initiative. And then, of course, our READY Hub, rigorous, rapid, and relevant evidence as adaptation and implementation to ending the HIV epidemic, which is part of a consortium of technical support hubs coordinated by the ISKI Center at Northwestern. So we're very pleased today to have as our guest speaker Inbal Billie Nahum-Shani, who's a research professor and director of data science for dynamic decision making at the Institute for Social Research at the University of Michigan. And she's been instrumental in quite a lot of work related to the SMART design that many of you have heard about and will probably hear a little bit more about today, and related designs that have been developed by her, Susan Murphy, and other very well-known statisticians who have been working in this area for quite some time. Just a little bit about Dr. Billie Nahum-Shani. She's a behavioral scientist who develops behavioral theory and novel methodology to construct adaptive interventions. These interventions modify the type, timing, dose, or delivery mode of support to address the unique and changing needs of individuals. Of particular interest are interventions that leverage digital technology to adapt intervention delivery to individuals in real time in their daily lives. Her work includes developing and extending experimental designs that can inform the development of adaptive interventions, including sequential multiple assignment randomized trials, or SMART trials, micro-randomized trials, MRTs, and hybrid experimental designs, HEDs. She provides leadership to several NIH-funded projects, including an NIH-NIDA-funded Ph.D. Center of Excellence to develop novel experimental designs and data analytic methods for adapting and personalizing services for drug use and HIV. And today, she'll be giving a talk on hybrid experimental designs for optimizing behavioral interventions. So I'm very pleased to turn over the virtual mic to Dr. Nahum-Shani, and we're very much looking forward to your talk.
Thanks so much, Donna. I'm really excited about the opportunity to be here with you all today. My talk, as Donna said, is going to focus on providing an introduction to a new experimental approach that we've been working to develop over the past few years. It's called a hybrid experimental design. And before I start, I wanted to, first of all, thank my amazing collaborators, and also NIDA and NCI for funding this work. I also wanted to mention that all the examples that you're going to see today, they're based on a funded project, an R01 funded by NIAAA, with Maureen Walton as the PI, but I modified all the examples for illustrative purposes. So this is not how these examples were implemented in practice. Okay, so let's start by talking about the gap that these designs are trying to address. You see, with recent advances in digital technologies such as EHRs, wearable devices, mobile devices, we have so many opportunities to increase the reach, the impact, the scalability of treatments. Now, with digital technologies, we can also monitor people continuously to obtain rich and granular information about their state and context, and we can use this rich data to adapt the delivery of support to their rapidly changing needs in real time in the real world. So there's tons of opportunities there. But I think that to fully take advantage of these opportunities, we have to figure out how to best integrate these components, these digital components, with human-delivered components. And the reason we need to think about this integration, it's because each modality brings its own advantages and disadvantages to the table. So as an example, I want you to think about human-delivered components such as coaching sessions. Okay? Coaching sessions can increase supportive accountability and therapeutic alliance, which can increase treatment engagement. And treatment engagement is critical for treatment success. But what's the downside? The downside is that these components are relatively expensive and relatively burdensome. Now, think about digital components, such as a prompt from the mobile device, encouraging you to take a walk, take a deep breath and count to 3, be mindful in the moment. These are relatively cheap and relatively, I would say, hopefully less burdensome compared to human-delivered components. But what's the downside? The downside is the suboptimal engagement of individuals in digital interventions across the board, different problems, different interventions. We see people using the digital tool a few times, and then they stop gradually or immediately, but they stop before they fully benefit from the intervention. So we have to figure out as a scientific community how to best integrate these digital components with human-delivered components so that people can benefit from both worlds. But the question is, how do we do that? You see, we don't know how to best integrate, sequence, and adapt human-delivered and digital components simultaneously. But what do we know? Okay, so this is just an overview of my talk. I'm going to mention a few definitions, but I'm going to repeat them later. What do we know? We know that human-delivered components, again, think about coaching, these can be adapted on a relatively slow timescale. And when I say adapt, I mean using dynamic information about the person to decide whether and how to intervene. And when I say slow timescale here, I mean over a few weeks or over a few months. Now, if you want to develop an intervention in which human-delivered components are adapted on a relatively slow timescale, it means typically that what you want to develop is what we call standard adaptive interventions or just adaptive interventions. Now, if you have scientific questions about how to best construct an adaptive intervention, there are existing experimental approaches that you can use, such as the sequential multiple semi-randomized trial, the SMART. Now, what do we know about digital components? Digital components, again, think about a prompt from the mobile device. These can be adapted on a much faster timescale. And when I say fast, I mean every few days, hours, minutes, seconds. Now, if you want to develop an intervention in which digital components are adapted on a relatively fast timescale, it means typically that what you want to develop is what we call a just-in-time adaptive intervention, or a JEDI. Some people call it JITI, but we prefer JEDI for obvious reasons. We all want the force to be with us. Mm-hmm. But if you want to develop a JEDI and you have scientific questions about how to best construct this intervention, there are existing experimental approaches that you can use, such as the MRT. But what if you want to develop an intervention in which human-delivered and digital components are integrated and they are adapted on multiple timescales, both slow and fast? What do you do if you want to develop a multi-model adaptive intervention? This is why we've been working to develop the hybrid experimental design. So what I'm going to do in this talk, I'm going to start by telling you more about adaptive interventions and the SMARTs, and then I'll tell you about JEDIs and the MRTs. And then I'm going to show you how these concepts are connected to multi-model adaptive interventions and the hybrid experimental designs. I'm going to show you how hybrid experimental designs can help us answer a wide variety of really cool scientific questions about how to best construct multi-model adaptive interventions, interventions in which human-delivered and digital components are integrated and adapted on multiple timescales. All right, but before I get to adaptive interventions, there are two things that I want to clarify. The first thing, this might seem trivial, is the difference between an intervention delivery framework and an experimental design. What is an intervention delivery framework? Sometimes we call it an intervention design. And I think that's why it's confusing. People confuse this with an experimental design. So what is an intervention delivery framework? It is the answer to the question, how should we deliver interventions in practice? And the we here is not researchers. The we are practitioners, the entities that actually deliver the intervention in practice, the coaches, the therapists, the digital tool. What guidelines or procedures or protocols should they follow when they implement the intervention in practice? That's an intervention delivery framework. So adaptive interventions, JEDIs, and multi-model adaptive interventions are intervention delivery frameworks. Okay, an experimental design, I know you all this, is the answer to the question, how should we, and now we is the researchers, how should researchers systematically manipulate independent variables so we can answer scientific questions that are important to us? Here, these questions are about how to best construct different types of adaptive interventions. In experimental designs, we have randomizations because we want to make causal inference about these questions. In intervention delivery frameworks, there are no randomizations because the goal is not to gather scientific information. The goal is to guide the delivery of interventions in practice. And when you guide the delivery of interventions in practice, when you give a protocol to someone, you're not randomizing, right? So no randomizations, adaptive interventions, HEDs, and multi-model adaptive interventions. I'm laughing because people still find it very confusing. All right. The second thing that I want to clarify is that all the trial designs I'm going to talk about today, these are optimization trials. These are not evaluation trials. So what is optimization? Let's be clear about what we mean. It's a systematic process in which you develop effective and resource-efficient interventions. This is the definition that Linda Collins has in her book about optimization. I like to think about this as the process of building a car. It's because Linda uses the term looking under the hood when she talks about optimization. So I'm thinking about building a car. So when you build a car, I've never done this before, but I find this process fascinating. You think about putting the parts together, selecting parts and integrating them in a way that will give you a car that is not just fast. It also has to be fuel efficient and potentially cheap and good for the environment and so on. And you have to do this. You have to put the parts together to produce an effective and a resource efficient car before you take it for a ride and compare it to other cars, right? So I think that's a nice metaphor. When you optimize, when you use these trial designs, smarts, MRTs, hybrid designs, your goal is to put together a high quality adaptive intervention package, effective and resource efficient package before you conduct a randomized, traditional randomized controlled trial where you compare this package to a suitable control. All right, so I think now we're ready to talk about adaptive interventions. So what is an adaptive intervention? I know I said that before, but I'm going to say it again, I promised. It's an intervention delivery framework. It's a guide for how practitioners should deliver interventions in practice. But it's special because it guides how practitioners should adapt interventions in practice. And by adapt, I mean use dynamic information about the person to decide whether and how to intervene. Now, the goal of adaptive interventions is to address not only the unique, but also the changing needs of people as they progress over time. And specifically, the goal is to address conditions that change relatively slowly over a few weeks or over a few months. And these interventions, they typically guide the adaptation of human-delivered components, but they can also guide the adaptation of other components that can be adapted on a slow timescale. So let me show you an example to make it concrete. This is an example of an adaptive intervention for youth in the emergency department, and it starts with a single session in the emergency department plus a digital intervention. The goal here is to reduce their substance use. At week 4, they assess the participant's response status. If the participant self-reported to use drugs at week 4, they're classified as non-responders and they transition to the second phase where they receive remote health coaching. This is human-delivered coaching. Otherwise, they continue with the same initial intervention. All right, so there are 2 things that I want you to know this year. The first thing, this intervention has an adaptation process. It's adaptive because we use dynamic information about the person's response status to decide whether or not to add coaching. The second thing, the adaptation here happens on a slow time scale. It happens at week 4. Why? Because we're trying to address conditions that unfold over 4 weeks. We're trying to address early signs of non-response to the minimal support that participants received earlier. That's why we adapt the intervention 4 weeks after the emergency department visit. That's why we adapt on a slow time scale. All right, this is nice and easy, but in many cases, we researchers have many scientific questions about how to best construct adaptive interventions. I want to show you 2 examples. The first question that I have is, should we really start with this relatively minimal form of support? I actually think that it might be better to bring coaching right off the bat instead of just this minimal support. I think it might be more beneficial in reducing the number of substance use days by week 16. So that's the first question. Should we or shouldn't we start with coaching? Second question. This intervention assumes that for non-responders, I should step up with coaching. But maybe it would be better to just continue with the same initial intervention. Just give them more time with the initial intervention. So that's my second question. Is it better to step up or continue for non-responders? The outcome that I'm focusing on here is a relatively distal outcome, reducing the number of substance use days by week 16. And later I'm going to show you an outcome that is more proximal. So I want you to see the difference between the two. Okay, so how do we answer these questions? This is where the SMART can be useful. SMART stands for Sequential Multiple Assignment Randomized Trial. So what is the SMART? The SMART is a randomized trial. It includes random assignment of participants to experimental conditions. But it's a special case of a randomized trial because it includes sequential randomizations. What does it mean, sequential randomizations? It means that the same person can get randomized multiple times in the course of the trial. In the SMART.
Sorry, Billie, can I ask a question?
Yeah,
there's been a lot of comments in the chat, or some.
Oh, I can't see anything.
That's
like
okay. I'll help you with that.
Sure, thank you.
What people are really happy about is that you clarified the distinction between an optimization trial versus an evaluation trial. And I think just to make sure it's all crystal clear about that, so the SMART design, and I don't know if all the designs you're discussing today are all for optimization trials. That's my first question. And then the second is, then after the optimization trial is conducted, then what happens?
Yeah, so that's a good question. So if the optimization trial is successful in the sense that it indicates what components you should include and how you should best integrate these components, then you put together an intervention package. Usually what you would do is conduct a full-scale traditional randomized controlled trial where you evaluate the performance of the package relative to a suitable control. Mm-hmm. That would be the natural course of things. Mm-hmm. But sometimes in optimization trials, you end up with results that you did not anticipate, mm-hmm. like null results. And then you wonder, why do I see that? And then you're thinking, maybe I should go back to the drawing board, or maybe I should implement the components differently. So you might go back to run another optimization trial. Does that make sense?
Sort of. I guess I'm just a little confused. In the optimization trial, you're figuring out what the rules should be, I think. But then in the evaluation, there's a fixed protocol that doesn't change anymore. Is that right? And it's just like you do something, something happens, and if the person does this, then you do that. And then you follow the person. If they do this, then you do that. But you know exactly what you're going to do if those things happen. Whereas in the optimization trial, you're figuring out what the best things are to do in response to the patient's kind of intermediate outcomes and so forth.
Yeah, you nailed it. Mm-hmm. Because so in the optimization trial, you're trying to figure out how to sequence and adapt the intervention component so you can come up with a high quality protocol. And as soon as you have a high quality protocol, this is when you have an adaptive intervention that you might want to compare to a suitable control in a traditional randomized control trial. Mm-hmm. So yes, when you're conducting a traditional randomized control trial, the assumption is that you have a good adaptive intervention package. You're not exploring, you don't need to answer any additional scientific questions about how to best construct it. You've got it, you have the protocol. Does that make sense?
Yes, it does to me. How about other people? Thumbs up.
Yeah. Okay, so please feel
I think we should go on so you have time to give your whole talk.
Yeah, and you can
stop. Yeah, we're seeing a few thumbs up anyway.
Sounds good.
Mm-hmm.
Okay, so sequential randomizations in the SMART means that the same person can get randomized multiple times in the course of the trial. In the SMART, each stage of randomizations corresponds to a point in time in the adaptive intervention that you're trying to develop, in which you, the scientist, you have scientific questions about the selection and adaptation of intervention components. So here's an example. Remember the two questions that I asked before. I don't know if I should start the intervention with coaching or without coaching. Because I don't know, as a scientist, I randomize to the intervention with or without coaching. You see? And then the second question was what to do for non-responders at week 4. I don't know if I should step up or continue. So instead of stepping up for non-responders, I randomize, because there's a scientific question. I randomize to step up versus continue. Okay? And responders continue with the same initial intervention. So notice the randomizations correspond to scientific questions. If you don't have scientific questions, don't randomize, okay? That's a very important rule. What I also want you to notice is that I'm randomizing on a slow time scale. I'm randomizing initially and at week 4. Why? Because I have scientific questions about what to do initially and what to do at week 4. Okay, I'm randomizing on a slow time scale because I'm trying to answer questions about how to best construct an adaptive intervention in which the adaptation happens on a relatively slow time scale. So there is a connection between time scale for the adaptation in the intervention that I'm trying to develop and the time scale of the randomizations and the trial design that I'm using to answer scientific questions about how to best construct this intervention. All right, so let me show you really quickly how to use.
So just to be clear again, so in the evaluative trial, there's no randomization at these different stages. We know what to do at every stage. The only randomization is whether they're in this dynamic protocol or they're in standard of care.
Got it. Yes.
That's right. Okay.
Okay. So let me show you how to use data from this trial to answer the 2 questions that I showed you, okay? Because it's kind of fun. I want you to notice that this design results in 6 individual experimental conditions, A through F, okay? And remember that my outcome is week 16 substance use, all right? So I want you to be in a mindset where I conducted the study, assume that I conducted the study and I collected the data. So the first thing I want to do is answer the scientific question about whether or not I should start with coaching when the outcome that I'm interested in is week 16 substance use. To answer this question, all I need to do is take the mean outcome across the 3 cells in which participants did not start with coaching, and I will compare it to the 3 cells in which they started with coaching. Do you see that? I'm comparing half of my sample versus the other half. This is just a 2-arm comparison, as simple as that, okay? That's the main effect of starting with coaching versus no coaching, averaging over subsequent components for responders and non-responders. Now, how do I answer the second question? Remember, the second question is only about non-responders. I want to know, should I step up or continue? So I'm only using data from non-responders, and I'm pulling outcome data across cells B and E, in which non-responders got the step-up option, and I compare it to C and F, in which they got the continue option. So I'm comparing half of my non-responders versus the other half. Just a 2-arm comparison among my non-responders. That's it. That's the main effect of the second stage components for non-responders averaging over the first stage components. Now, I want you to notice that in both cases, I'm not comparing individual cells. I'm combining outcome data across multiple cells in different ways to answer multiple scientific questions about how to construct this adaptive intervention. And that's why smart designs are so efficient for that particular purpose, for answering scientific questions about constructing adaptive interventions. All right, so I think we're ready to talk about JEDIs. What is a JEDI? A JEDI, just like an adaptive intervention, it's an intervention delivery framework. And just like an adaptive intervention, it guides how we should adapt interventions in practice. It guides how we should use dynamic information about the person to decide whether and how to intervene in practice. But in JEDIs, the adaptation happens on a much faster time scale, every few days, hours, minutes, seconds. Why? Because we're trying to address conditions that change relatively fast. And these conditions are not just changing fast, they're also changing in people's daily lives outside of standard treatment settings. And that's why JEDIs, they typically guide the adaptation of digital components, because digital components can be used to adapt intervention delivery rapidly, and they can be used to deliver intervention to people in their daily lives. So for example, I want you to think about the digital intervention that youth receive in the emergency department from the previous example. And suppose that as part of this intervention, we're asking people every day about their state and context. We're using EMAs to ask them about their stress, their loneliness, their hopefulness every day. And we also use GPS to monitor their location. And if this combined information indicates that the person experiences high risk for next day substance use, we trigger a message with a protective behavioral strategy. Otherwise, we do nothing. So you see there's an adaptation process here, similar to the previous example, because I'm using dynamic information about the person's risk status to decide whether or not to trigger a message. But now the adaptation process happens every day. It happens on a much faster timescale. Why? Because I'm trying to address conditions that change fast. I'm trying to address risk for next day substance use, which can unfold on a daily basis. So I adapt the delivery of the message on a daily basis. So again, this is nice and easy, but we researchers have many scientific questions about how to best construct the Jedi. And I want to share two questions with you. First of all, I don't know if we should trigger a message that contains a protective behavioral strategy. If this message is good overall, relative to no message in terms of reducing next day substance use. I just don't know. And then the second thing that I don't know is under what conditions this message would be most beneficial. This assumes that I should trigger a message when risk is high, but maybe it would be better to trigger the message when risk is moderate to high. Notice my outcome. It's proximal, reducing next day substance use. How do I answer these questions? This is where the MRT, the micro-randomized trial, can be useful. What is the micro-randomized trial? Just like the SMART, the MRT is a randomized trial that includes sequential randomizations. Again, meaning that the same person can get randomized multiple times in the course of the trial. But in the MRT, the sequential randomizations happen on a much faster timescale. What does it mean in practice? It means that the same person can get randomized hundreds and thousands of times in the course of the trial. And the length of the time interval between stages of randomizations is relatively short. Here's an example. Remember that I don't know if I should trigger a message or not, and under what conditions. And because I don't know, what I can do is I can still collect data every day from EMAs and from sensors about the person's state and context. But instead of triggering a message when risk is high, because I don't know if I should, I randomize every day to the message versus no message. You see that? And then I can collect information about the proximal outcome, next day substance use. So I'm randomizing on a much faster timescale every day because I have scientific questions about how to best construct the Jedi in which the adaptation happens on a fast timescale. So again, see the connection between the timescale of the adaptation and the timescale of the randomizations. All right, let me show you how to use data from this trial to answer the questions that I showed you, because actually I think it's quite simple. It only looks complex. Remember the first question. The first question is it better to trigger a message with a protective behavioral strategy or not in terms of reducing next day substance use? To answer this question, again, suppose that I collected the data, okay, conducted the study, collected the data. Remember, my outcome is proximal next day substance use, and it's measured following each micro-randomization. What I do to answer this question is I take the mean outcome across all the days, see in green, in which a message was sent, across all participants, and I compare it to the outcome across all the days in which a message was not sent across all participants. This is cool because my entire data, all my participants, and all the times in which they got micro-randomized will be used to estimate this effect. This is the average main effect of delivering a message versus no message on next day substance use. It averages over all participants and all the time points in which they got micro-randomized. And to estimate this effect, I'm going to leverage both within-person and between-person contrasts in my proximal outcome. And that's why MRTs are so efficient for answering scientific questions about constructing a Jedi. And of course, what I can also do is look at moderators of this effect. So I can see under what conditions a message is better than no message. And my favorite analysis, look at the time trend. See how this effect varies with time. Sometimes it dissipates, sometimes it intensifies with time, which is really interesting. All right. So I think now we're ready to talk about multi-model adaptive interventions, because guess what? Sometimes people want to combine adaptation on a slow time scale and adaptation on a fast time scale. Here, what I want to do is I want to be able to take this adaptive intervention that I showed you earlier. I want to start with a single session in the emergency department plus a digital intervention. And then I want to adapt the delivery of coaching based on the participant's response status at week 4. But at the same time, I want the digital intervention to use dynamic information about the person's state and context to adapt the delivery of the messages on a daily basis. It makes sense to do them both at the same time, simultaneously. In other words, here I want to develop a multi-model adaptive intervention. A multi-model adaptive intervention, similar to standard adaptive intervention, similar to HEDs. It's an intervention delivery framework. It guides how we should adapt interventions in practice. But what multi-model adaptive interventions do is they guide the integration of human-delivered and digital components that are adapted on multiple timescales, slow and fast. And you can think about it as an integration between a standard adaptive intervention and a HED. But again, we have tons of scientific questions about how to construct these multi-model adaptive interventions. And I want to share just one question with you that I'm personally very, very interested in and have been for many years now. I want to know if there is a positive synergy or a potential for positive synergy between starting this intervention with coaching instead of minimal support and delivering a daily message. The reason I'm interested in this potential synergy is because I think that by starting with coaching instead of minimal support, we can increase supportive accountability and therapeutic alliance, which will increase engagement with the message. So the message will be more effective in reducing next day substance use if we start with coaching. But how do I answer this question? To answer this question, I will need a trial design that will allow me to randomize sequentially to both human-delivered and digital components on multiple time scales, slow and fast, simultaneously. And this is exactly what hybrid experimental designs do. You see, what I can do to answer the question about the synergy as well as other questions about this multi-model adaptive intervention is take the SMART that I showed you before, where we first randomized to the intervention with or without coaching. Then at week 4, we randomized non-responders to step up and continue, and responders continue. But at the same time that this happens, every day I collect information about the person's state and context from EMAs and sensors, and I micro-randomize to the message versus no message. So I randomize on 2 timescales, slow to the human-delivered components and fast to the digital components. So that's a hybrid design that integrates the SMART and the MRT. Now, how do we analyze data from this study? Right? Again, it's simpler than you think. So I want you to be, again, in the mindset where I conducted this trial and I collected the data, okay? And suppose that now that I have the data, the first thing that I want to do before we talk about the synergy, the first thing that I want to do is focus on whether or not, on average, I should start with coaching in terms of week 16 substance use. Okay, so the question again is, should I start with coaching or not? Is it better to start with coaching or not in terms of week 16 substance use? To answer this question, all I need to do again is to take the mean outcome of week 16 substance use across the 3 cells in which participants did not start with coaching, compare it to the 3 cells in which they started with coaching. Again, just a 2-arm comparison. That's all. Similar to the analysis that I would do when I only had the SMART without the micro-randomizations. But because now I have the micro-randomizations, the interpretation of the effect is different. Because now this is the main effect of starting with coaching versus no coaching, not only averaging over subsequent interventions for responders and non-responders, but also averaging over the delivery of the daily messages. Because the MRT is happening in the background. All right, now I want you to assume that the second thing that I want to do with the data is, again, figure out if overall, on average, it's better to deliver a message versus no message in reducing next day substance use. Again, all I need to do is an analysis that is similar to the analysis that I would do if I only had the MRT. I would take the mean outcome of next day substance use across all the days in which a message was sent across all participants and compare it to all the days in which a message was not sent across all participants. The same analysis, but now the interpretation is different. Because now this is the average main effect of delivering a message versus no message on next day substance use, not only averaging over all participants and all the time points in which they got micro-randomized, I'm also averaging over the delivery of first stage and second stage components in the SMART, because this is happening in the background as well, okay? And now I think we're ready to talk about the synergy. Because you know how to estimate the effect of delivering a message versus no message on next day substance use. You know how to do that. And remember, the question about synergy was about the difference between this effect, between starting with coaching versus no coaching. I want to know if the effect of delivering a message is amplified if I start with coaching versus no coaching. So all I need to do is estimate the effect that you know how to estimate now among half of the sample who did not start with coaching, estimate this effect among the other half who started with coaching, and compare the two. It's kind of like difference between differences. An interaction, a difference between two effects. Delivering a message versus no message if people did not start with coaching, and delivering a message versus no message when people started with coaching. And this interaction will tell me if the effect of delivering a message is amplified, if it's stronger by starting with coaching. Okay. So data from hybrid designs can be used to answer a wide variety of scientific questions about how to best construct multi-model adaptive interventions. And I like to organize these questions into two buckets, okay? The first bucket, the green bucket, is for questions that focus on the proximal effects of the digital components. And I call these proximal effects because they focus on the proximal outcome, like next day substance use. And here you can ask questions and answer questions about the average effects of the digital components, averaging over the human delivered components, or how they interact with the human delivered components. So that's one bucket. The other bucket, the purple bucket, I call it a bucket that focuses on questions that concern the distal effects of the human delivered components. And I call it distal effects because these questions usually focus on the distal outcome, like substance use by week 16. And here again, you can ask questions about the average effect of the human delivered components, averaging over the digital components, but also how they interact with the digital components. I'm going to show you an example in a second. This manuscript here provides a list of scientific questions that you can answer with a hybrid design that integrates the SMART and the MRT. And this manuscript also includes code in appendices that you can use to plan sample size for hybrid designs, but also analyze the data. The entire focus here is on a hybrid design like the one that I showed you that integrates the SMART and the MRT. But there are various types of hybrid designs depending on your scientific questions. So this manuscript here provides an introduction to 3 different types of hybrid designs. All right, before I open it up for more questions, I actually wanted to show you preliminary results from a real hybrid design that was implemented, completed, we analyzed the data. But it's preliminary analysis. This is with Bonnie Spring as the PI. It's an R1 that was funded by NIDDK, sorry. And Bonnie's team is currently analyzing the results with additional data than what we had. So these are preliminary results. Okay, so this is a study that focuses on building a multi-model adaptive intervention for obese and overweight adults. The goal is to help them lose weight. At the beginning, we randomized participants with equal probability to either a weight loss app alone or the app plus coaching. Response status was assessed at week 2, 4, and 8. As soon as participants showed insufficient weight loss based on a pre-specified definition, they were classified as non-responders and they transitioned to the second phase where they got randomized to either a modest step up or a vigorous step up. Otherwise, they continued with the same initial intervention. So what's the difference between modest and vigorous? Modest means that all non-responders received subsequently text messages. That's it. Vigorous means that they received text messages plus a traditional component that they did not receive earlier. So specifically, if I did not respond to app alone and got vigorous subsequently, it means that I got text messages plus coaching sessions because I didn't get coaching initially. If I did not respond to app plus coaching and got vigorous, it means that I got the text messages plus meal replacement because I already got coaching initially. So now I got the text messages I got the meal replacement in addition to the text messages subsequently. The most important thing to keep in mind, in both step-ups, participants, non-responders receive text messages, But we didn't just deliver text messages, we actually micro-randomized. Every day around noon, participants were micro-randomized with 2/3 probability to either a message or no message. And the messages focused on encouraging them to self-monitor their dietary intake. And that's why the proximal outcome was whether or not they self-monitored the dietary intake in the next 12 hours. And the distal outcome was month 6 weight loss. All right, so I want to show you preliminary results for one of the questions that we're really interested in. This question only focuses on non-responders. It focuses on a distal outcome, month 6 weight loss, and it concerns an interaction between the human-delivered and the digital components, and it's actually a 3-way interaction. You ready? We wanted to know if the effect of starting with coaching versus no coaching on month 6 weight loss varies for non-responders depending on the type of step-up that they received and the rate of messages that they received. So it's a 3-way interaction between starting with coaching versus no coaching, the type of step-up, and the message delivery rate, only among non-responders, okay? Because only non-responders get the text messages. And let me show you the results. So what you see on the y-axis, that's the estimated weight loss. On the x-axis, these are the first and second stage components that participants receive. And inside, these dots represent different rates of message delivery. So the red one means that the message delivery rate was at the sample mean, meaning that participants received the message on 64% of the days. Green means that the rate of message delivery was 1 standard deviation above the mean, meaning that the participant received the message on 74% of the days. And blue means standard deviation below the mean. Participants received the message on 54% of the days. So what you see is that if people started with app alone, it doesn't really matter what kind of step up they received and what was the message delivery rate. They did not lose much weight. But look at those who started with coaching and then all they got subsequently was the text messages. For these people, higher message delivery rate was associated with greater weight loss, much greater weight loss. So this is interesting because it seemed to be a positive synergy between coaching and the digital messages, but only for this group. Look at this group. Those who started with app plus coaching, then they got text messages plus the meal replacement. For them, higher message delivery rate is less beneficial in terms of weight loss. And this is interesting. We think that this has to do with burden because this group received so many components, the app, the coaching, then the meal replacement and the text messages, maybe higher message delivery rate for these people, too many messages was just too much, was too burdensome. All right, before we open it up for questions, I think we have time only for a few. I wanted to mention that our website includes tons of resources that you can use to design these studies, to analyze data from these studies, and so on. So please check it out for those of you who are interested. And that's it. That's all I have. Happy to open it up for questions if people have.
Yeah, thanks so much, Billie. We really appreciate this talk. It was very clear and very interesting. So I know there's a person in the chat who wrote a detailed question. I suggested that he ask the question at the end of the talk. His name is Bashir Susuna. And by the way, you might not realize this, but we have a number of collaborations with people around the world, and there are literally people on this Zoom call from all over the world. So Dr. Bashir, would you like to ask your question?
Yes, sure. The way I have understood, or the way I understand smart designs, they optimize the sequence or timing of the intervention for individuals based on their initial responses or their responses over time. So my question is, for the intervention that we include in this smart design, does it mean that it has already been proven effective, or we can use any intervention, whether effective or not? The second question is, since in most designs, we optimize the intervention itself, to know which one is effective. Can we use these these designs in a sequence, for example, on the same individuals, that I can first get the effectiveness of an intervention from the most, then I go ahead with a smart design? Thank you.
These are really good questions. So let's
And
start
if you don't
with-
remember because it's a detailed question, if you're able to open the chat now, you would see point 1 and point 2 that could help you.
Yeah, the problem, as I said, as soon as I
Oh, you can't see it.
with the
Okay,
slide,
don't worry about it. I'll
Sorry
tell
about
you.
it's the way the system here is set up.
Oh.
But okay, so let's start with the second. With the first one, if I forget the second, I hope I won't, then you can remind me. So the first question, if I understood it correctly, was do we have to have components in a SMART that were already proven to be effective, or can we use whatever components we want? So I highly recommend to use components that you have already shown to be feasible, acceptable, and that based on existing evidence and theories, you think that there's much potential in these components as part of a sequence. Because if you don't, then it's tricky. You might have a component that you've never tried before. You don't know if it's feasible, if it's acceptable. So I think that would be more challenging for you to get the results that would be informative to you in terms of helping you build a high quality intervention package. So I do recommend including components that you have evidence of feasibility and acceptability and potential effectiveness in the SMART. The second question, the way I understood it, you're asking if in the same study, we can have kind of like a sequence of trials, maybe one where we can have a SMART to optimize the adaptive intervention and then later evaluate the intervention compared to control, or maybe have a study that combines the SMART and a standard randomized control trial. Did I understand the question correctly?
Well, more specifically, what was written in the chat was, can we say apply the same two designs on the same individual? For example, most and SMART. Like, how might we integrate most and SMART?
Oh, okay.
Is that right, Dr. Bashir?
Yes, that's correct.
Okay, so this is an even better question than I thought. It's because it's very interesting. I have two reactions to that. One is when you say most, actually, I think that you mean a factorial design. And you need to correct me if I'm wrong, but many people, they conflate the two. They think that most is all about factorial designs. Did I get this right? You mean like a factorial design and a SMART design, if you can do them together in the same trial? Yeah?
Oh, yeah.
Okay.
Since most designs are optimized intervention itself to get the most effective.
Yes. Yeah. So perfect. So the second paper that I mentioned, the one in behavioral research methods, actually one of the hybrid designs, it's an integration between a factorial design and a SMART. And I can tell you that there are many scientists that are interested in this kind of a design. This year alone, I think I designed 2 of them. It makes a lot of sense if the first thing that you want to do, the first stage, you want to screen out multiple components. For example, you want to know if you should start with coaching, yes or no, if you should have a mobile app, yes or no, if you should have text messages, yes or no, if you should start with meal replacement, yes or no. So you want to screen out all kinds of components that you might want to consider for the first stage. And then you also want to identify non-responders and figure out what is the best step up for these non-responders. So that way you integrate the factorial design and the SMART. And it's actually an extremely efficient experimental design. So if you're interested in something like this, I highly encourage you to go to that second paper that I mentioned. There's a figure there. It's really nice. Yeah, it looks like I'm giving myself compliments. Actually, someone helped me with putting together these figures. But there are two forms of these figures that show you how this randomization can happen, both to the factorial design and the SMART within the same trial on the same participants, and you still have sufficient power to detect effects, even with a reasonable sample size. Does that help?
Sure. Thank you very much.
Other questions? Anybody? Well, while people are thinking, I have one, of course. So can you put the last slide up, which was the example?
I can try.
Okay. And while you're doing it, I'll say, so my question is, so after, what is then the result of that optimization trial? Like, what is the output? And I think I know what it is. It's like, first you should do this, and then if the person does that, then you should do that, and then if the person does that, then you should do this. And then these other options that were randomized to, that were found to be not as statistically good, are dropped. And then you evaluate the ones that are chosen in the evaluative trial compared to what?
Yeah. Okay, so
I think at
was
the
half,
very
I'm
end.
sorry about that, because I was half listening to you and half was trying to put
Oh, okay. I can
No,
say
no,
it
but you're
again.
fine. I think I got the question. So hold on a second. Let me just make
So
sure.
I think maybe if you go to, if you go to like this slide, maybe?
Yeah. You wanted this one?
Well, I was gonna go up a little bit more, actually. Yeah, like here. So
Yeah.
you randomized here to decide whether app or app plus coaching is better. And then based on the analysis, you would conclude, you might conclude that app plus coaching is significantly better. So
Yeah.
then in the evaluation trial, everybody gets app plus coaching, or they get nothing.
Yeah.
And then in, let's say, and then you might conclude that the vigorous step up actually wasn't any better than the modest step up. So
Yes.
then in the evaluation trial, there's no randomization here.
Yeah.
All non-responders go to modest step up.
Yeah.
And then that's the evaluation trial. So you have a dynamic treatment regime, but there's no more randomization. We know exactly what to do at each step.
Yes.
And then we're comparing. And what would you compare it to? Would you really compare it to standard of care then, which might be just app plus continue?
Yeah. I mean, if the standard of care includes an app, you know, sometimes the standard of care in weight loss is not even that.
I know.
But I would probably include an app. I would have the standard of care where a physician would recommend an app for participants to use, and I would compare it head to head, the optimal adaptive intervention, the optimal sequence that we have identified to that standard of care.
And then is that second evaluative trial called a SMART trial anymore, or what is that called?
No, it's called a standard randomized control trial. There's evaluation.
But it's a dynamic treatment regimen, though.
It's true. It's a traditional randomized control trial in which what you compare to control is an adaptive intervention. But the trial itself is not as SMART because you don't have sequential randomizations, right? What makes the SMART a SMART is that at least one person can get randomized more than once in the course of the trial, right? Typically, some or all of the participants get randomized more than once in the course of the trial. So if your scientific question is about, is my adaptive intervention package better than control? And you randomize once to either the adaptive intervention package versus control, then that's not a SMART. That's a standard randomized control trial that focuses on evaluating the performance of your adaptive intervention.
Okay, yeah, good. And then just, practical question. Well, two actually, are people able to get funding for both in the same, say, R01 or even something less for the SMART part piece and then the evaluative piece, or does it end up being two different grants?
Yeah, typically these are two different grants.
Wow.
Because both are full-scale studies. You would need a full-scale SMART. Here, the number of participants is 400. So with the 5-year R01, there's no way that you can accommodate 400 people for the optimization trial for the SMART, and then 400 people for the RCT. for the traditional RCT. It's just, it takes too long, and also it's very expensive. So you would need an R01 that is focused on the full scale optimization trial, the SMART or the MRT or whatever it is. And then the follow-up grant in your program would be an evaluation RCT, where you compare the package that you have identified as optimal to a suitable control.
Yeah, so we're talking about 10 years to just identify a single dynamic to establish, firm evidence for a single dynamic treatment regimen. So
single intervention, yeah.
That's really, quite daunting.
But it's better, but think about it, Donna, it's better than not doing this. Like,
Yeah, no, of course.
this process. And then you build a package, you build an adaptive, I've seen it so many times, people build an adaptive intervention, then they get funded to do an RCT to evaluate it relative to control. Then there are now results. They don't understand what was going wrong. They have no clue.
Yeah, I know.
And then they have to go back to the drawing board, and so many times, so many resources have gone lost, right? So I think this is an important step in the direction of building more effective and scalable interventions, because we first optimize it. Look, you're not going to buy a refrigerator or a car thinking that, people just put the parts together without really optimizing it, right?
I know.
In the same way, I don't want to give people an intervention before I know that I did everything within my power to make sure that the intervention is effective and resource efficient before I compare it to control.
Yeah, I mean, I guess I'm just thinking because of the time factor, these are like critical public health issues as well, that we really don't want to wait 10 years
I agree.
to figure out how to help people lose weight or stop abusing drugs. So I was thinking just out loud, maybe in the spirit of most, maybe the SMART piece could be more with like intermediate, very quick outcomes, that are, sort of surrogates for the big outcome, to get to get some kind of reasonable idea of what the intervention would be, and then do the evaluation. But anyway, it is 3.
I like that.
This was an incredible talk. This is great cutting edge work, and we're just thrilled that you were able to do this. And thank you so much, and thanks everybody for joining and being part of our audience.